Hello everyone. This week we're going to look at the topic of congruence. But before we get into that, I just want to explain to you what's going on in school and online. So in school, you're going to be looking at the topic of circle theorems. So you're going to have one lesson a week over the next 4 weeks. But that's going to cover the topic of circle theorems. Your online lessons are going to be completely separate. So you're going to be looking at different topics online based on the revision survey that you did for me a while back. So that's going to be later on. That's what you're going to be doing online. They're going to be separate topics each week, but in school you're going to be doing circle theorems. And at some point as well, you're going to have another Google form assessment to do. So you're going to have like a little test of 10 questions, multiple choice, and you just got to click the right answer. But that will be kind of like not this week, but maybe the following week, but when I get a chance to make it. But it'll be on all the topics we've done so far. Okay, so let's kind of not waste any time. We're going to be looking at the topic of congruence. So your 3 online lessons this week are going to be lesson number 1. It's an introduction to congruence. So we're going to look at some basic rules and some examples. Lesson 2, we're going to look at some proving stuff with congruence or proof. And then lesson 3 is some questions for you to have a go at, which, like as before, I wanted to submit this for checking, please. And by the way, can I just say a big thank you to all those people, and there's loads of you who are submitting your work on time, but you're also marking it and giving me a grade. And also thank you very much for all those people who write little comments about what they got stuck on, or little things they want me to explain or check, because that's fantastic, guys. I really kind of appreciate you doing that. The big thing is that everyone's marking their own work, because it takes ages to download the work, and sometimes the file formats are very different, and sometimes the picture quality isn't very good, and it's difficult for me to mark everyone's work. But I really appreciate those people that are making the effort to do that. Thank you very much for that. Okay, so let's kind of not wasting time. So this week, in this lesson, lesson number 1, we're going to look at the basic rules regarding congruence. There's only one video for you to watch, and then I want you to just have a go at a couple of questions. It won't take you very long to do, and it's exercise 6, page 188. And then I just want you to do questions 1 to 8. Yeah, I mean, you can do as many as you want. You can do more if you want, but those ones for now would be sufficient. Okay, so let's get into it then. Congruence. What's it all about? Okay, let's just recap what we did last week. Okay, these 2 triangles here are similar. Remember what similar means. Similar means they are just a copy of the triangle, but slightly smaller or slightly bigger version of like a shape. So similar means it's just a copy, but one slightly bigger or one slightly smaller. So that's what similar means. And you can tell that they're similar because the angles in the corners are the same. So this angle matches this one matches this one, and this third one matches this third one. But they're not identical triangles. They're just a copy of each other, but one's slightly bigger version. So there might be some scale factor, or 2 or 1 or 2 or 1.5 or 3 or whatever. But one's a slightly bigger version of the other. Congruence means that, for example, these 2 triangles here in blue are congruent because they actually are the same triangle. So here, for example, in sort of like simplistic terms, congruent means that these 2 triangles are actually the same triangle. They're both identical to each other. And you can easily see that they're identical to each other because, first of all, the angles in the corners are the same. They match each other. So for example, this one matches this one matches this one, and this one matches this one. But the sides also match each other. So there's this one here matches this one, and this one here matches this one, and this third side matches the third side here. So these 2 triangles have to be the same triangle. They are what we would say congruent. They're identical to each other. Or you can think about it as when the scale factor is kind of like 1. I mean, for example, here the scale factor is probably like 2 or 3 or something, but here they are kind of like scale factor 1. They're actually just a copy of each other. They're exact copy of each other. But when we talk about congruence, we don't really care about the orientation. So it could be the mirror image or rotated round. We don't really care about that. We just want to know if they're the exact same triangle. Okay, now there are 4 things to look for in congruence, and we're going to go through those 4 rules or four types of congruence right now. Okay, so first one, type of congruence number 1, is when you have this scenario. And by the way, we're only looking at triangles for today, and actually in congruence we generally look at triangles anyway. But here's congruence type number 1. These 2 triangles are actually identical. They are congruent, and here's why. First of all, they have this in common. First of all, this side here matches this side here, because remember the dash means they're the same length. So these 2 are the same length. We don't know what the length is, but they are the same. And then this second side is the same length as this side here on the other triangle. And then the angle between those 2 sides is also the same. Okay, and sometimes that angle between 2 sides is called the included angle. But these 2 triangles are congruent, and you need to think about it in a logical way. So for example, if I just kind of made up some measurements, for example, let's say for example this side was 5 centimeters long, and the angle between the 2 sides is 40 degrees, and this side 7 centimeters. So this would have to be 5 then, and this would have to be 7, and that angle would have to be 40. Well, by kind of like logic, that third side there would have to be the same as that third side there. And you can easily calculate it because you could use the cosine rule. Remember that cosine rule? A squared plus b squared equals... Sorry, remember this one? 2bc minus... Sorry, I'll keep saying it wrong. B squared plus c squared minus 2bc cos a. Do you remember that rule? Well, you could use it to work out that third side because you've got 2 sides of the angle between them. We're not going to do that though. But it'd be the same calculation for both because there's 5, 40 and 7. So 5, 40 and 7. So this third side would be the same. And then you could go on to use the sine rule to work out the angles in the corners and show that they're the same. So this one would be, the orange one would be here, and this one would be the same. So if you knew the lengths and the angle, if you knew the actual value of them, then you could use a bit of trigonometry to work out all the missing information like the side and the angles, and then you could show that they're the same. But you would just be proving that they're identical. But the thing is though, what we're trying to do in congruence is not do that extra work. I don't want to do all that trig and all that kind of like heavy calculation. But we don't need to do that because we've got enough information to say that these 2 triangles are congruent. And this is the thing to look for. The thing to look for is side, angle, side. And it's abbreviated to SAS. So what we mean by that is if you have 2 triangles, and by the way, it doesn't matter if you know the angles or the lengths or not. Remember, we're just looking at the dashes for sides and how many arcs are drawn in the corners for the angles. But if you have the following scenario where you have one side matches one side, so you have a side, and then you have another side matching the other side on the other triangle, and then you have the angle between them is the same. That's important though. This angle here has to be what we call the included angle, or the angle between those 2 sides. If they're the same as it is in here, then these 2 triangles are congruent. They're actually the same triangle. They're just upside down or, you know, mirror image or whatever, but they are the same triangle. They are congruent to each other. And you don't need to do any trig to prove it or any other kind of calculations at all. If you have that scenario, they've got to be the same triangle. Okay, that's rule number 1. Or sorry, type of congruence number 1. Okay, let's look at number 2. Okay, type of congruence number 2. Okay, so if you have this scenario where you have one angle in a triangle matches another angle, an angle in another triangle, sorry, and then you have another angle matches an angle in the other triangle, And then you have a side that comes off one of the angles, matching this one here. For example, you have this scenario. Then those two triangles have to be congruent. And here's kind of like, just using numbers, for example, I just want to prove to you why that is. So for example, if I just make some numbers up, let's say this is 10 centimeters long, so then this one would have to be 10 centimeters long, and I'm just making these numbers up. So let's say that's 35 degrees maybe, and let's say this is 50 degrees, so then this would have to be 35 degrees, and this would have to be 50 degrees. So let's say you have these two triangles where you've got these measurements here, so 10 centimeters and 35 and 50 degrees. Well, these two triangles are actually the same triangle. They are identical to each other. And here's why. First of all, this angle here would have to be, well, okay, just, take it away from 180, right? Okay, I've made up a really stupid angle, but I should have made that a bit much bigger, but this would have to be 95 degrees. I've done some really stupid here, I'm really sorry. But then this one here would also have to be 95 degrees, even though it's not drawn accurately at all. But you've just shown that the angles are the same, right? Okay, because they would be, because both triangles have to add up to 180. So if two of them are the same, the third one's got to be the same by default. And then because you've got this 10 centimeters matching this 10 centimeters, then they have to be the same triangle. Because remember I said to you, well, okay, here for example, the only difference between similarity and congruence is if the scale factor is 1. Well, first of all, we've just shown that the angles match each other. But for example, you could say that the scale factor between these two triangles is 1, because that's 10 and that's 10. And they both come off the 35 and 95 degree side. So that's important. They both come off that side here. Sorry, both these angles, they come off the 95 and 35. They both come from the same angle. So the scale factor is 1, therefore all the other sides have got to match each other as well, because you've got this scenario here instead of this scenario here. So if that kind of makes sense, so they have to be the same triangle. So they can't be anything different. And I mean, and you can prove it in lots of different ways. For example, you could use you could use cosine rule to work out the missing sides and show that they're the same. So for example, hang on, that's 35, the 50, 35. So these two sides are the same. So you could use a bit of sine rule to work out that side there, for example, to show they're the same. But we don't need to do all that heavy kind of calculations and so on. We got enough information to show that. So this is kind of like the thing to look for, the summary of it. Okay, so the thing to look for is angle, side, angle. So this is the thing to look for, angle, side, angle. So let's just go through how to use this rule. So first of all, if you have an angle that matches another angle matches an angle in another triangle, that's the angle. And then if you have the following, you've got a side coming off that angle, matching a side coming off the same angle in the other triangle. That's important as well. So you see that this green angle here, the side comes off that green angle, so it's got to be the same here. And then if you have at least one other angle matching, so you've got this angle here matching this angle, then they've got to be the same triangle. They've got to be identical to each other. They are the same. They are congruent. That's what we say. Congruent means they are the same triangle. They're just upside down or mirror image or rotation, but they are the same triangle. And we abbreviate it to ASA. So angle, side, angle. Okay, let's just quickly go through the other two. Okay, this one's the easiest one, and it's kind of obvious, but you might need to think about it a little bit. But if you have two triangles where the sides match each other, for example here I've got this side matches this side here, this second side matches this second side here, and this third side matches this third side, then those two triangles have to be congruent. They have to be the same triangle because they really couldn't be anything else. And here's why. For example, if I just kind of put some measurements on them, again, I'm just making this up. So let's say that's 5 centimeters. Let's just say it's centimeters. 5 centimeters, 6 centimeters, 8 centimeters. So then this one would have to be 5, 6, and 8 centimeters. Well, using a bit of like cosine rule, you could work out this angle, for example, using, remember, cos A equals, do you remember this one, b squared plus c squared, take away a squared over 2bc? Then that, whatever calculation you do to work out that angle on this triangle would be the same for this one, because remember how it works. So remember, your A is the opposite side to the angle you want, so this would be your 6, so that would go there where the A is, and the B and C would be the 5 and 8. But it would give you the exact same angle every time you do it, and then you could do it again for another corner and show that they're the same. But why bother doing that? Because you've got all the enough information to show, without kind of like any other calculation necessary, that these two triangles have to be congruent to each other. They have to be the same triangle. They're exactly a copy of each other, just kind of rotated round. So this is the thing to look for: side, 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 or SSS. So I mean, it's kind of self-explanatory, but if the three sides on both triangles kind of match each other, so this one matches this one matches that one matches that one, then those two triangles have to be congruent. They have to be identical to each other. Okay, and the last rule. This one's the easiest one of all. Okay, so if you have two right-angled triangles, so you have the following scenario. So first of all, they're both right-angled triangles. So here's your right angle. And then the hypotenuse, remember the hypotenuse is the longest side. They both have the same hypotenuse. And then they've got one of the shorter sides the same. So for example, this second side here, matches this side here. So these two triangles have to be the same, right? Because logically speaking, I mean, if I were to just put some numbers on it, so if I said to you that's 12 and that's, I don't know, 7 or something, and this is 12 and this is 7 centimeters, then you can use Pythagoras to work out that third side. It'd be 12 squared, take away 7 squared, square rooted, wouldn't it? But then it would be the same for this side here. This would be the same length because you do the same calculation. 12 squared, take away 7 squared, square rooted, right? And then you could use maybe some SOHCAHTOA to work out this angle here. So you do cos to the minus 1 of 7 over 12. But then you do the same on this triangle. But then you get the same answer, wouldn't you? Because it's the same calculation. So you get the same angles and the same sides. But why bother doing all of that? Because you've got all the information you need to say that these two triangles are the same. So this is the only thing you need to look for. So you just need to look for the following: right angled. So what I mean by that is right angled triangle. So that's right angled. And then hypotenuse. So do they have the same hypotenuse? Yes, they do. They both have the same hypotenuse. And then do they have one other side which is the same? They do. So therefore they must be congruent. So they have to be congruent because they couldn't be any different from each other. Ignoring the orientation. So the rule is right angled, hypotenuse, side. So that's kind of like the final rule to look for: right angled, hypotenuse, side. And this is just the summary of it here. So these are the 4 main rules that we tend to use in congruence proof. So we look for side, angle, side. Remember, the angle has to be the one that's in between or include between the two sides. So side, angle, side. So then these two triangles are congruent. Angle, side, angle. Or side, side, side. Or right angle, hypotenuse, side. And they're the 4 ones that you need to kind of know to prove anything is congruent. Okay, so now it's probably a good idea for you to have a look at this exercise here. Okay, So that's the exercise I'd like you to have a go at. Thank you for watching, guys. Your next lesson is more kind of to do with proof and it's a bit trickier. Okay, thank you for watching, guys.